elements mainly consists of definitions, axioms, and postulates. Definitions are explanations that consist of certain undefined terms which are acceptable. Axioms and postulates are assumptions of actually obvious universal truths in which postulates are specific to geometry and axioms are used throughout mathematics and not specifically linked to geometry. Now, let's consider Euclid's postulates. Euclid had written 5 postulates in his Elements. Let's discuss on each of them. A straight line may be drawn from any one point to any other point. Consider a set of points on a plane. Let's select 2 points A and B. Now draw a line joining these 2 points. Now check if you can draw another line passing through points A and B. It is impossible, right? So we can say that only one straight line can be drawn from 2 distinct points. However, we can draw as many lines passing through a single point A or B, which may be passing through some other point, say C. That is, only one line can be drawn between A and C. However, Euclid had frequently assumed without mentioning that there is a unique line joining 2 distinct points. We state this result in the form of an axiom as follows. Given 2 distinct points, there is a unique line that passes through them. Now, let's see the next postulate. A terminated line can be produced indefinitely. The term terminated line is what we call a line segment nowadays. So, according to the present day terms, the second postulate says that a line segment can be extended on either side to form a line. Here, we have extended the line segment AB to an indefinite line. The third postulate is a circle can be drawn with any center and any radius. Consider an xy plane. We can choose any point, say P, whose coordinates are -2, -1. Considering this as the center, let's choose a radius of 2 units. Using a compass, we can draw a circle with P as center and 2 units as radius. Now, the fourth postulate is all right angles are equal to one another. Be it in any direction, a right angle is 90 degrees and is equal to one another. And the final postulate is that if a straight line falling on 2 straight lines makes the interior angles on the same side of it taken together less than 2 right angles, then the 2 straight lines, if produced indefinitely, must meet on the side which the sum of the angles is less than 2 right angles. So let a line L fall on 2 lines M and N, intersecting at A and B respectively, making interior angles alpha and beta on the left side. Also, the sum of alpha and beta is less than 180 degrees, that is 2 right angles. Then, if we extend the left side of the lines M and N, they meet or they intersect. Now, postulate 5 is far more complex than any other postulate. On the other hand, postulates 1 through 4 are so simple and obvious that these are taken as self-evident truths, although it is not possible to prove them. So, these statements are accepted without any proof. Postulate is actually a verb. When we say let us postulate, we mean let us make some statement based on the observed phenomenon in the universe. Its truth or validity is checked afterwards. If it is true, then it is accepted as a postulate. Nowadays, postulates and axioms are terms that are used interchangeably and in the same sense. Euclid also used them to prove other results. Then using these results, he proved some more results by applying deductive reasoning. The statements that were proved are called propositions or theorems. Euclid deduced 465 propositions in a logical chain using his axioms, postulates, definitions and theorems proved earlier in the chain. Now, let's see a theorem with its proof, which is frequently used in different results. Two distinct lines cannot have more than one point in common. So, if we are given two lines L and M, we need to prove that they have only one point in common. For the time being, let us suppose that the two lines intersect in two distinct points, say P and Q. So, you have two lines passing through two distinct points P and Q. But this assumption clashes with the axiom that only one line can pass through two distinct points. So, the assumption that we stated with that two lines can pass through two distinct points is wrong. Now that we have familiarized with the 5 postulates, let's see which of these statements are true. The first one is only one line can pass through a single point. This statement is false since through a single point an infinite number of lines can pass. The next one is there is an infinite number of lines which can pass through two distinct points. It is false since through two distinct points only one line can pass. We can prove that with the first postulate. The next one is a terminated line can be produced indefinitely on both the sides. This statement is true. Also, it is clearly mentioned in the postulate 2. And the last one is if two circles are equal, then their radii are equal. This statement is true because if two circles are equal, then their center and circumference will coincide and hence the radii will also be equal. Now, we have already discussed on the 5th postulate, which is complex and very significant. From this, we can also imply that no intersection of lines will take place when the sum of the measures of interior angles on the same side of the falling line is exactly 180 degrees. There are several equivalent versions of this postulate. One of them is Playfair's axiom. It is stated as, for every line L and for every point P not lying on L, there exists a unique line M passing through P and parallel to L. Here you can see that all the lines passing through the point P, only one line M is parallel to line L. This result can also be stated in the following form. Two distinct intersecting lines cannot be parallel to the same line. Now let's see an example. Consider the following statement. There exists a pair of straight lines that are everywhere equidistant from one another. Is this statement a direct consequence of Euclid's 5th postulate? Explain. Take a line L and a point P not on L. Then by Playfair's axiom, which is equivalent to the 5th postulate, we know that there is a unique line M through P which is parallel to L. Now the distance of a point from a line is the length of the perpendicular from the point to the line. This distance will be the same for any point on M from L and any point on L from M. So these two lines are everywhere equidistant from one another. So we can conclude that Euclid's postulates are assumptions specific to geometry, and there are a total of 5 postulates, and Euclid used the definitions, axioms and postulates to prove other results. Then using these results by applying deductive reasoning, he proved some more results or statements that are called propositions or theorems, which are a total number of 465.